going to talk about DevSecOps with SaltStack. I mean, that appears to be the most trendy name to get people into sessions, so I thought, why not, right? So I'm going to talk about DevSecOps with SaltStack, shift security to left and not right. A few things about me. My name is Mehul Revankar. I'm a product manager at SaltStack for security. Before I came in here, I ran the research team for Tenable. If you've used Nessus ever in your lifetime, so all the Nessus plugins and Nessus plugins, audit files, all of those came out from my team. So I have a short agenda. I'll discuss what DevSecOps is, why we need to shift security to the left and not right, some advantages of doing that. And once I'm done with the theory aspect of it, I'll walk through a really trivial example so that we can all bring that concept together so that it makes sense. And I'll use some examples with Salt orchestration, beacons, reactors, and hopefully it all makes sense and it's worthwhile for your time to come here. So thank you for coming in. So let's start off. So why do DevSecOps, right? The purpose and intent of DevSecOps is to build the mindset that everyone is responsible for security. It's not just like the dev team or the security team or the operations team. It's like everyone's responsibility at this point. And so how do we get to a point where we deploy applications into productions without compromising on security, without compromising on the dev side of things, and also the operations side of things, right? So if you look at it, the dev, ops, and they're three completely different roles. So if you're a developer, you're thinking about writing stable code, error-free code, performant code, and reusable code, and so on and so forth. So that's your mission. That's what you're going after. That's what you care about, right? And if you're on the operations team, or if you're part of operations, you're thinking, I just want to make sure this application never goes down. I have high uptime, fewer shortages or outages, and everyone is happy. And if something goes down, put it back right on there, right? So that's your operations mandate, if you will. And on the security side, you don't care what these guys wrote. I just want to make sure they are all encrypted and secure, and there are no vulnerabilities. And regardless of how crappy the code is, I just want to make sure you don't have any vulnerabilities in there, right? So if you think about it, it's three completely different roles, right? I mean, there is very little overlap, and yet they're expected to deliver on a single goal. And that goal is deploy a securely configured application into production. And that's all, at the end of the day, that's all we care about, right? And in an ideal world, you would imagine all these three roles are equal partners to accomplish this goal. Like, dev does their part, ops does their part, security does their part, and there is a lot of collaboration that goes on to get to a point where you deploy an application. There are no vulnerabilities, no configuration issues, and so on and so forth. But in reality, what happens is you have your dev team, right? They write their best piece of code they've ever written, and they're like, hey, ops guy, go deploy this code. And the ops guy is like, oh, let me try. He goes and tries it. Hey, doesn't work. And what version do you have? Right? And then he makes some changes, adds some files, does a git pull, or does something else, and he comes back and says, sorry, never mind, works now. Add the wrong file or whatever. And then he asks, hey, by the way, what about security? Right? And did you do anything about it? And the dev goes, well, what about security? That's not my problem. And then two of them, they come together, and they're like, and there's the security guy, probably in the basement or somewhere else, right? Hacking away at stuff, and he's like, let's ask him to run a quick test. So they go back to the security guy and say, hey, bye. We got this production grade code, can you run a quick test for us so that, we go live next week, and let's see how it goes. The problem is, it doesn't work. Once you have this siloed approach, misconfigurations pop up, compliance violations pop up. You have major vulnerabilities like hard bleed in production. Sometimes applications just don't work because the devs come back, it works on my laptop, and the ops guys are like, it doesn't work in production. I'm sure you guys have run into these situations before, right? And so that approach doesn't work anymore. And the reason this happens is, in a typical application development process, you spend a lot of time in planning for the application. Once you plan the application, you design the application, you go, get all the requirements, and you start developing it, you test it, and by the time you have used up all the time you said you're going to deliver this product, and then you come to like the final deployment phase, and just before that you do security review and go with it. And security historically has been shifted to the right of this process because from a business perspective, just business perspective, it doesn't add any value, right? If you are like an MBA, well, I have this functional product which solves the use case we said we are going to solve for this user, and we have this user who's going to pay us $100 for solving this problem, and they cannot go back and say, well, you'll get an insecure app for $100 and then a secure app for $200. You cannot do that. So the assumption from the user is that security is probably baked in. But security considerations usually slow down the teams, and they have to make a lot of design changes and considerations and so on and so forth. So there's always this push from the business side of things, let's get the functional aspect working, and then we'll figure out the security when we come to it. And that is true until something like Equifax happens, right? If you know the impact of Equifax, I was reading some statistics before coming to this session. Just because Equifax did not patch that Apache Struts vulnerability, they lost, I believe, 31% of their market share, or $5 billion in their market cap. And you can imagine this was probably one update script somewhere, right? They just had to plug that into some script somewhere to update Apache Struts every time we went to production. It's crazy. So then security suddenly starts to become a focus, like, we have to be secure, and so on and so forth. And when this happened last year, I was in the thick of, I worked for Tenable, so I was in the thick of actually developing the logic for detecting Apache Struts. And I could see the pressure on the CISO side. Like, can you get this done in 6 hours? And then they would call our support team, because they were looking for vulnerability definitions from Nessus to, we want this now. The CISOs, the CEOs, and they're calling them every hour. Do we have Apache Struts in our infrastructure? What's going on? Do we have Apache Struts? Where is it? So it was very scary for me because we didn't have a solution, and our devs were working, over time to get a fix out. But that kind of crystallized how important security becomes if you cannot ignore it for long. Eventually, it comes back, and it hurts really bad, right? But thankfully, the times are changing, right? Thanks to adoption of agile development practices, the teams are coming together, and they realize that security is everyone's responsibility now. We cannot just, we just cannot expect the security team to do their stuff and not do it on it. And when you deploy applications, they have to be secure by default, right? But the biggest challenge I've seen is how do we even get started? What's the step one? Forget about getting these teams together. How do we get these teams to talk to each other? Right? That's the first problem. These teams don't even talk to each other. So there are a lot of things you could do to do this. You could set up a CI/CD pipeline. You could add like dynamic application security testing and vulnerability testing and static code analysis as part of your CI/CD pipeline. You could train the developers to just write secure code and so on and so forth. But in this talk, I don't want to get into like how do you configure Salt to be part of integrate with all these other tools and so on. I want to do more basic than that. What's like the first step? And in my view, the first step is to actually start by writing your infrastructure or expressing your infrastructure as code. Right? Once you do that, there are a lot of advantages of doing that. So once you express your infrastructure as code, like the dev, sec, and ops team on sync on what's been deployed, where it's getting deployed, how it's getting deployed, everyone is assured, right? The security team is assured that there are no keys or credentials that are getting leaked out. The ops teams are certain that's the right version they're deploying and where they're going to get deployed. And if for some reason one of the members doesn't like what they see, they can just create a pull request, preferably against Git, propose a fix, and then the teams can review it. Well, yeah, that looks good, and merge into production, and then we start to get this collaboration going, right? That's in my view, that's probably the first step of the process. So I said, in the agenda, I'm going to talk about an example with SaltStack. So let's take an example of how you would put this into application. How do you apply this concept, right? So let's say there's a custom application that needs to be deployed. It requires a Redis server, requires a web server, and a project group. Pretty trivial app. Maybe does print, just does hello world. I don't know, but very simple, very trivial. And we'll use a SaltStack orchestration file, a beacon and a reactor, and see how things come through. So has anyone used orchestration before? Yeah. One hand, two hands. Okay, good. It's a single file, which and you can add references to remote execution modules in it. You could add references to a state file, state modules. Runners, wheels for managing keys and minions, and so on and so forth, right? So, and it will completely allow you to express the entire infrastructure that needs to be deployed in a single file, right? And obviously, there will be dependencies within it with state files, and there will be other files to it, but that would be a very high-level overview of all the things that need to be deployed as part of this process. Here's a good example of Salt orchestration file. You have an ID declaration. You could do salt.function, a name, a target. You could call salt.state, multiple states, multiple SLS files, and so on and so forth. I mean, the syntax remains pretty much constant. And then once you're done, you could say salt run state.org and the file name, and it just goes, and Salt does its thing. It goes and deploys it, and it's all good to go. So let's come back to our example, right? So we need to deploy Redis servers. So we'll have a state file for Redis. We'll have a state file for the web servers, few dependencies like Python. We'll make sure, you could have it so that you could have these conditionals so that this requires the Redis to be deployed before you deploy the web servers. Once the web servers are deployed, you could go and deploy the project group, and the project group depends on the web infrastructure. Pretty simple, straightforward, 3 simple steps to achieve what we need to do, right? So in this case, I have a simple Redis state file. All it's doing is it's downloading Redis, you make an install, and you finally install it. And I could have actually used Jinja templates. I realized it today, but I wanted to express, from a visual perspective, like from an operations team, I want to deploy 4.0.10, right? And I wanted to express it without actually going to a Jinja.map file. So I put it all there in this simple, and all of it came in a single screenshot. I was like happy, Hopefully the audience will understand, right? so you go here, install, you go and install Redis. So before we go much deeper into this discussion, let's talk about a word on security from Redis, right? And this is from Redis website, and this is not something I wrote. This is something from Redis. It says Redis is designed to be accessed by trusted clients inside trusted environments. This means that usually it is not a good idea to expose Redis instance directly to the internet, or in general to an environment where untrusted clients can directly access Redis TCP port and Unix socket. So if you're part of the security team and you look at this, you've never heard of Redis, and you see this, and what do you do? What do you do? You could do, there are three options, right? You could say, do nothing, right? It's never an option, but you could always do nothing, but then you'll always get blamed for it when something goes wrong, right? Why did you raise some concerns about it, right? You could say, well, you can go back to the developers and say, hey, can you not use Redis? And you can see a visceral response from the dev side, like, who the hell tells me what to use and what not to use? Like, you could see a visceral response from the dev side. Like, I have to use Redis. I've tested my application. It works with Redis. We have to use Redis. And you can almost see like a war forming, right? That's not going to happen. And the most pragmatic thing at this point could be, you know what? I'm going to just propose some fixes for this Redis, and then I'll take it from there. And in terms of proposing few fixes, they could say, you know what? Let's make sure that no one can modify the configurations. Simple. Make sure the owner can make changes to it. Let's make sure you have some configurations for the data directory so that no one accidentally get access to the data directory on Redis. And then you go, you know what? Let me enforce a password requirement on it as well. Right? So you could do these basic three things. And you could also say, in addition to that, you know what? Go back and add some IP table rules so that you only connect to it from trusted clients, and you deny everything so that it takes care of the concerns that they have. I mean, if you look at the Redis statement, make sure you have only trusted clients connecting to it, right? So you restrict it to the ports that you wanted to access from, you deny everything else. Pretty reasonable, right? I mean, you don't have to take Redis out of your infrastructure. By the way, I'm not ignoring the people on this side. I'm just a lefty, so please don't mind. So I can't point this over there. So you propose an IP tables rule, a few changes to the Redis state file. And then once you have this, you would update the Redis state files to include the file permission changes, the password requirement, and then you would update the orchestration file to have a reference to the IP tables rules, and you're all good to go. Right? So one of the advantages of doing this is just because you did this, as a byproduct, you also satisfy a lot of compliance regulations. Like if you have ever read PCI DSS requirement 2, it talks about having secure configuration, right? So just because you just did some due diligence on this, you also satisfied PCI requirements for this deployment. If you have ever read the CIS controls, the critical controls, the section 5 of that talks about having secure configurations for your workstations and servers and so on and so forth. And finally, 853 specifically calls out for having password authentication for your information system. So you didn't do anything at this point. Excuse me. You didn't have to do anything special, and yet you were able to get a securely configured app, and which is satisfying compliance mandates by default. So you're secure by default, compliant by default, and hopefully, production ready by default. So now, now that we have taken care of the security considerations for this application, let's talk about the operations side of things. And initially, I talked about the operations team. Their responsibility is to maintain high uptime and prevent outages and so on. And you can do that. You can do that with Salt, right? So you have the first concern is are you deploying the right versions of the applications, right? So you can do that because your orchestration file clearly, explicitly lays out what versions are going to be deployed, where they're going to deploy it, and so on and so forth. You could create Salt beacons. So if you've never heard of Salt beacons, it's a way for you to monitor processes, files on any asset that has a minion installed. So if you have a minion installed, the beacons, you can configure beacons to generate an alert when something like, for example, Redis stopped. You could have it generate an alert. It goes back to the event bus, and you can do something about it, right? And finally, Salt has something called as Salt reactors. Salt has something called as Salt reactors, which can actually take actions based on those events. I mean, anyone who has worked with a SIEM realizes, you're already getting flooded with events. I mean, if you just get an event, what's the point? I mean, at some point, you're maybe for the first week or two, you'll look at all these events, and then you'll be like, you become completely immune to it, right? So, it's always good to, if there is an event that happens, to be able to take some actions on it. So what you could do here is you could write a Salt, beacon for let's say for this example, since we love Redis a lot, let's make sure if the state of Redis changes, let's generate an alert. And beacons are like designed for this purpose. Like you can be very specific on the criteria to trigger an alert, and you can modify and change it as you feel needed, and the beacons will go out and do their job. And the good thing I like about beacons is that it doesn't take a lot of CPU. It sits there, it does its thing. As soon as something happens, it generates an alert. It goes on the event bus and goes on to the next thing. So it's not something like it's running in the background, taking up your CPU and so on and so forth. So I really love the concept of beacons. But what good are alerts if you can't do something about it, right? So what you could do in the next step is you could tie it up with a reactor, and the reactors can be configured similar to beacons to do something when a criteria is matched. So I merged two files here. So in the first file is actually the reactor configuration, which has a tag for Redis. So as soon as you see an event from the Redis servers, go and invoke the state file, and it goes out and it invokes the state file in the bottom, which says go and restart Redis server. And when I was trying this as part of I always got a kick out of it. I could never get Redis to stop, because as soon as it stopped, it started it back up. I could never get Redis to stop. So at this point, what we have achieved is the devs are happy. They don't have to get rid of Redis. The ops team is happy because the application never goes down, or even if it goes down, they're creating, they're able to keep it up. And the security guys are happy because they have made sure that there is the security considerations are taken care of. So you're always connecting to this application from trusted clients. So that was my talk on DevSecOps. A few takeaways on this. So I've always heard this. It's that it's too difficult, and we don't have all the tools, and so on and so forth. And I think that was true a few years ago. But with technology, with the Salt technology that we have, I think it's getting much more easier to start this journey. And so it's never too late to start on this journey, and especially with the Salt remote execution capabilities, orchestration files, Salt reactors, and beacons, you can have the complete setup done without actually going out. And Salt also integrates with a lot of applications and services, so you can tie it as part of your CI/CD pipeline, and so on and so forth. So I can totally see you can hooking it up with something like Tenable or Qualys for your VM assessments, and so on, right? It's time it's time to move security to the left of the process, and you start to collaborate much sooner on the project rather than keeping it to the last minute and then getting screwed up like Equifax or Target. And one of the best things in my view is to start expressing infrastructure as code. And once you are there, I think there will be a lot of resistance to get there, but once they see the value, once you start creating pull requests left and right, this is not working, that is not working, and propose fixes, I think this product eventually becomes much more stable over time. Initially, you'll run into some hiccups and so on and so forth, but eventually, hopefully, it should be a good story. And last but not the least, leverage salt beacons and reactors. In my view, they are the salt beacons and reactors are super, super, super powerful. And so for somebody who's new to salt, they don't take advantage of the beacons and the reactors as much as I would like them to use. But they are really powerful once you get a hang of it. I mean, I still get a kick out of it every time I try to kill Redis. It never stops. It comes back right up, and it's almost instantaneous. And obviously, it's in my lab, so you have to account for that. But still, it's still insane that I cannot kill Redis on my. So yeah, that's all I had. So, any questions? No? Cool. Thank you.